The global economy is witnessing the most significant escalation in economic warfare since the Cold War. Not through military confrontation, not through currency manipulation, not through traditional trade tariffs, through something far more devastating: the systematic weaponization of critical minerals that modern technology cannot function without. What started as U.S. semiconductor export controls has escalated into China's gallium and germanium embargo that threatens to collapse Western technology infrastructure. And the mathematics of retaliation are unforgiving. Let me show you exactly how this escalation unfolded. Let me walk you through the numbers that prove neither side can back down. And let me explain why this represents the end of the integrated global economy and the beginning of competing technological blocks that will reshape geopolitics for the next century. Because when you understand the resource dependencies, when you see the production concentration, when you recognize the impossibility of rapid alternative supply development, you realize this is not trade policy. This is economic warfare designed to force technological submission through resource control. The retaliation chain is accelerating beyond diplomatic resolution, and both sides are trapped in escalation dynamics that lead only to complete economic decoupling. Every economic warfare campaign in history followed identical escalation patterns. Initial sanctions target strategic industries. Counter-sanctions target different but equally strategic sectors. Escalation continues until one side achieves dominance or both sides destroy mutual economic benefits. The US-China technology war has reached the final phase where complete decoupling becomes inevitable. October 2022 marked the escalation trigger when the United States implemented the most comprehensive semiconductor export controls in modern history. Advanced chip manufacturing equipment exports to China faced complete prohibition. Semiconductor design software licensing was terminated. American citizens working in Chinese semiconductor companies were forced to resign. The economic impact was immediate and devastating. Chinese technology companies lost access to cutting-edge processors essential for artificial intelligence development, 5G infrastructure deployment, and advanced manufacturing automation. NVIDIA graphics cards, Intel processors, and TSMC manufacturing capacity became inaccessible to Chinese firms through export license requirements that were designed to be impossible to obtain. But the Biden administration underestimated Chinese retaliation capacity through critical minerals control. China's response took 15 months to fully implement, creating the false impression that Beijing lacked effective counter-escalation options. The delay was strategic preparation, not weakness. March 2023 witnessed the first Chinese countermove through gallium export licensing requirements that created artificial scarcity and price increases for global semiconductor manufacturers. This was a warning shot designed to demonstrate Chinese leverage without triggering immediate crisis. Western governments failed to recognize the signal. December 2023 marked the full Chinese retaliation through comprehensive gallium and germanium export prohibitions to all countries maintaining semiconductor export controls against China. No licenses, no exceptions, no appeals process. Complete embargo designed to force Western technology companies into impossible choices between Chinese market access and critical materials access. The mathematical reality is brutal because Chinese resource control approaches monopoly levels that cannot be quickly circumvented. China produces 95% of global gallium supply through integrated aluminum smelting operations that generate gallium as a byproduct. Alternative gallium sources exist, but require 5 to 7 years of development investment exceeding $50 billion. Germanium production concentration is equally concerning, with China controlling 60% of global refining capacity and holding strategic reserves accumulated over decades when prices remained low. Russia controls additional 20% through integrated mining operations. Combined Chinese and Russian control over 80% of germanium supply creates duopoly pricing power that Western economies cannot overcome through market mechanisms. The United States faces complete vulnerability through zero domestic production capability for either metal, despite consuming 30% of global gallium supply and 25% of germanium supply for semiconductor manufacturing, defense applications, and renewable energy systems. Strategic stockpiles total approximately 6 months of normal consumption levels, which provides minimal buffer against sustained embargo. European allies face identical vulnerability with additional complications through energy dependence on Russian natural gas that limits policy coordination with American sanctions. Germany's chemical industry depends on both Chinese gallium and Russian germanium for specialty applications that support automotive electronics and industrial automation systems. The economic mathematics become clear through impact analysis across affected industries. Smartphone production requires gallium arsenide semiconductors for 5G connectivity and power amplification systems. Global smartphone shipments total 1.4 billion units annually, worth approximately $800 billion at retail prices. 5G infrastructure deployment requires gallium nitride semiconductors for base station power amplification and signal processing. Each 5G base station contains approximately 15 grams of gallium compared to 3 grams for 4G systems. Global 5G infrastructure investment totals $200 billion annually, with gallium representing a critical component that cannot be substituted through alternative materials. Electric vehicle production increasingly depends on gallium and germanium semiconductors for power electronics, battery management systems, and autonomous driving capabilities. Tesla, BYD, and other manufacturers face production constraints within months unless alternative supply arrangements can be negotiated at premium prices that eliminate cost advantages over internal combustion vehicles. Defense applications create national security implications through F-35 fighter aircraft, missile guidance systems, radar installations, and satellite communications equipment that require gallium and germanium semiconductors for operational effectiveness. Pentagon stockpiles provide limited protection against sustained embargo designed to last multiple years. But the retaliation impact extends beyond direct material consumption through supply chain disruption effects that cascade across interconnected manufacturing networks. Semiconductor foundries like TSMC require continuous gallium supplies for advanced node production that supports Apple, NVIDIA, and Qualcomm chip designs. Production interruption affects downstream device manufacturers globally. The pricing mechanisms reveal embargo effectiveness through spot market dynamics that demonstrate Chinese pricing power over remaining supplies. Gallium prices increased 400% within 3 months of embargo announcement. Germanium prices increased 250% over identical time frame. Price increases reflect genuine scarcity rather than speculation. Alternative supply development requires massive capital investment and extended timelines that make immediate substitution impossible. Gallium extraction from aluminum production requires specialized equipment and technical expertise concentrated in Chinese operations built over decades. Recreating equivalent capacity requires minimum 5 years, assuming cooperative regulatory approval and adequate financing. Germanium mining and refining present similar challenges through geological concentration in deposits that require complex metallurgical processing to achieve semiconductor-grade purity levels. Canadian, American, and Australian deposits exist, but remain undeveloped due to previous Chinese pricing that made Western production uneconomical. The geopolitical implications multiply through alliance relationships that face stress testing over conflicting economic interests. Japan and South Korea maintain security partnerships with the United States, while depending heavily on Chinese manufacturing inputs for Samsung, Sony, and Toyota production operations. The European Union faces impossible choices between supporting American technology sanctions and maintaining access to Chinese critical minerals essential for renewable energy transition goals. German automotive industry depends on Chinese rare earth supplies for electric vehicle motor production while facing American pressure to reduce technological cooperation with Chinese companies. Taiwan's position becomes increasingly precarious through TSMC dependence on Chinese gallium supplies for advanced semiconductor production that supports both American technology companies and Chinese electronics manufacturers. Cross-strait economic integration creates vulnerabilities that military planners cannot ignore during crisis planning. The technological implications extend beyond current production into research and development capabilities that determine long-term competitive advantages. Chinese control over critical materials provides leverage over Western innovation in artificial intelligence, quantum computing, renewable energy, and defense technologies that depend on advanced semiconductor capabilities. American technology companies face strategic choices between accepting Chinese material dependencies or accepting performance degradation through alternative materials that cannot match gallium and germanium specifications. NVIDIA graphics cards lose computational efficiency without gallium arsenide components. Intel processors face thermal management challenges without germanium enhancement. The financial markets reflect escalation uncertainty through semiconductor stock volatility and supply chain diversification investments that reduce short-term profitability for long-term security objectives. Technology companies announce alternative sourcing initiatives that require years of development and billions in capital investment with uncertain success probabilities. Chinese technology companies simultaneously face advantages and disadvantages through domestic critical mineral access, combined with advanced semiconductor design restrictions. Huawei, SMIC, and other firms can access materials but lack cutting-edge manufacturing equipment needed to produce competitive products for global markets. The military strategic implications become clear through defense industrial base analysis that reveals critical vulnerabilities in weapon systems production. F-35 fighter aircraft production faces potential interruption through gallium shortage affecting radar and communication systems. Missile guidance systems require germanium infrared sensors that cannot be produced without Chinese cooperation. Space launch capabilities face similar constraints through satellite communication equipment and guidance systems that depend on critical mineral inputs for reliable operation in extreme environments. NASA, SpaceX, and defense contractors maintain limited stockpiles that provide temporary protection against supply disruption. But stockpile management presents its own challenges through material degradation and technological advancement that makes inventory obsolete before consumption. Gallium and germanium require specialized storage conditions to prevent oxidation and contamination that affects semiconductor performance. Strategic reserves lose value through technological evolution that demands higher purity standards. The economic modeling demonstrates mutual destruction potential through bilateral trade worth $230 billion annually that faces complete elimination if escalation continues to logical conclusion. American technology exports to China total $120 billion annually, while Chinese critical mineral and electronics exports to America total $110 billion. Job market effects cascade through engineering, manufacturing, and support services that depend on integrated supply chains operating at maximum efficiency. Semiconductor industry employment exceeds 2 million workers globally, with additional 5 million in downstream applications that face disruption through critical material shortages. Regional economic impacts concentrate in technology hubs like Silicon Valley, Austin, Boston, Shenzhen, Beijing, and Taipei, where semiconductor design, manufacturing, and assembly operations cluster for supply chain efficiency. Local real estate, services, and supporting industries face recession through reduced technology activity. The currency implications create additional instability through trade balance adjustments and reserve asset reallocation that affect global financial markets. U.S. dollar strength depends partly on technology export demand that faces reduction through Chinese substitution efforts. Chinese yuan stability requires export revenue that sanctions reduce through market access limitations. Central bank policies must adapt to supply chain inflation and strategic industry support that conflicts with traditional monetary policy objectives. Federal Reserve faces pressures to support domestic semiconductor development through favorable credit conditions while managing inflation from critical material price increases. International development aid programs face restructuring as technology transfer restrictions limit assistance effectiveness in countries that require advanced industrial capabilities for economic development. Chinese Belt and Road Initiative gains advantages through continued technology cooperation that American programs cannot match. The climate change implications affect renewable energy transition timelines through solar panel, wind turbine, and battery production that requires critical minerals for efficiency optimization. Gallium arsenide solar cells achieve higher efficiency than silicon alternatives, but require Chinese material cooperation for large-scale deployment. Electric grid modernization faces delays through smart grid technology that depends on advanced semiconductors for load management, renewable integration, and cybersecurity protection. Power grid reliability depends increasingly on sophisticated electronics that require critical mineral inputs. But the most significant long-term impact involves technological sovereignty development, where both nations prioritize domestic capability over economic efficiency. American industrial policy shifts toward domestic semiconductor manufacturing through CHIPS Act investments that require parallel critical mineral development programs. Chinese technology policy emphasizes indigenous innovation and import substitution that reduces dependence on Western technology while leveraging natural resource advantages for geopolitical influence. Made in China 2025 goals accelerate through controlled access to critical materials that Western competitors require. The timeline for resolution remains unclear because both sides face domestic political pressures that prevent compromise while economic costs continue escalating. American elections create pressures for tough China policies that limit negotiation flexibility. Chinese leadership faces legitimacy challenges if perceived as surrendering to Western economic pressure. Military planners prepare for extended economic conflict that resembles Cold War dynamics more than traditional trade disputes. Pentagon develops contingency plans for critical material substitution and strategic reserve expansion that assume Chinese embargo continues indefinitely. Technology companies implement supply chain diversification strategies that increase costs and reduce efficiency while providing security against future disruption. Intel announces gallium recycling programs and alternative material research that require massive investment with uncertain outcomes. The mathematical conclusion becomes clear through cost-benefit analysis that demonstrates mutual economic destruction through continued escalation without diplomatic resolution. Neither side can achieve complete victory without accepting enormous economic costs that undermine the strategic objectives, justifying initial escalation. But game theory analysis suggests escalation continues because neither side can afford to appear weak during early phases of technological competition that will determine geopolitical leadership for decades. First-mover advantages in artificial intelligence, quantum computing, and advanced manufacturing create existential stakes that transcend normal economic calculations. Market mechanisms cannot resolve resource concentration that provides monopoly pricing power during geopolitical tension. Alternative supply development requires government intervention and strategic cooperation that conflicts with current political dynamics in both countries. The critical minerals war represents a fundamental shift from economic integration toward technological blocks that prioritize security over efficiency. Supply chains will reorganize around political alliances rather than comparative advantages, creating permanent inefficiencies that reduce global living standards while increasing geopolitical tensions. This is not temporary trade. Dispute resolution through negotiation and compromise. This is structural transformation toward competing technological spheres that cannot be reversed through diplomatic engagement alone. The retaliation chain has achieved momentum that forces complete economic decoupling regardless of leadership preferences. The $230 billion trade relationship faces systematic destruction through escalation dynamics that create prisoner's dilemma outcomes, where cooperation becomes impossible despite mutual benefits from continued economic integration. Both sides are trapped in escalation logic that leads inevitably toward competing technological blocks with minimal economic interaction. The critical minerals embargo represents the weaponization of resource interdependence that makes future cooperation impossible without complete strategic surrender by one side. The mathematics of retaliation guarantee continued escalation until one economy achieves complete technological independence, or both economies accept permanent inefficiency through parallel development of identical capabilities. Neither outcome seems politically acceptable to current leadership in Washington or Beijing. Market forces cannot overcome geopolitical logic when national security considerations outweigh economic efficiency. The invisible hand fails when visible hands control critical production inputs for strategic advantage rather than profit maximization. The global economy is fracturing along technological lines that will reshape international relations for the remainder of the 21st century. The critical minerals war is just the beginning of complete economic decoupling between the world's two largest economies. The escalation continues because the stakes are existential and the mathematics of mutual destruction provide no clear path toward de-escalation that preserves strategic objectives for both sides. The semiconductor industry faces the most severe bilateral damage, with the United States losing approximately $89 billion in annual revenue, while China experiences $76 billion in corresponding losses. This represents 34% of total U.S. semiconductor exports and 42% of Chinese semiconductor imports, creating supply shortages that cascade through global electronics manufacturing. 5G infrastructure development suffers 18-month deployment delays in the United States, as gallium shortages prevent base station production, while China faces complete market isolation from Western 5G equipment manufacturers. Global 5G rollout stagnation affects economic productivity improvements, projected at $2.3 trillion over the next decade. Electric vehicle production cuts impact both economies through different mechanisms. American EV manufacturers face component shortages that reduce production capacity by 27%, while Chinese manufacturers lose export market access worth $34 billion annually. Price increases averaging 15% globally slow electric vehicle adoption and climate change mitigation efforts. Defense systems present critical vulnerability for U.S. military readiness, as F-35 fighter aircraft, missile guidance systems, and radar installations require continuous gallium and germanium supplies. Chinese defense advancement slowdown occurs through restricted access to advanced semiconductors essential for hypersonic weapons and artificial intelligence military applications. Global arms race costs increase as nations develop alternative supply chains for strategic weapons production. Global gallium demand totals 450 tons annually across all industrial applications, with semiconductor manufacturing consuming 68%, solar panels requiring 22%, and defense applications utilizing the remaining 10%. Available non-Chinese supply reaches only 180 tons annually, creating a supply gap of 270 tons, representing a 60% shortage that cannot be resolved through market mechanisms. Alternative supply development requires minimum 5 to 7 years for new mining operations, refining facilities, and quality certification processes. Investment requirements exceed $50 billion for equivalent production capacity, assuming cooperative regulatory approval and adequate technical expertise transfer from existing operations. The mathematical impossibility of rapid substitution forces Western technology companies into impossible choices between accepting Chinese material dependencies or accepting performance degradation through alternative materials that cannot match gallium and germanium specifications for advanced applications. The October 2022 U.S. chip export ban triggered immediate $45 billion revenue loss for Chinese technology companies through restricted access to advanced processors, manufacturing equipment, and design software. Chinese artificial intelligence development, 5G deployment, and advanced manufacturing capabilities faced immediate constraints that continue compounding monthly. March 2023. Chinese gallium restrictions represented the first retaliation phase through export licensing requirements that increased global prices by 400%, while creating artificial scarcity for Western semiconductor manufacturers. This warning shot demonstrated Chinese leverage without triggering immediate crisis response from affected industries. December 2023, full mineral embargo implementation placed $230 billion in bilateral trade at risk through complete gallium and germanium export prohibition to countries maintaining semiconductor sanctions. No licenses, no exceptions, no appeals process designed to force Western technology companies into strategic submission. The 20D24 and beyond projection indicates complete economic decoupling as competing technological blocks develop parallel supply chains, manufacturing capabilities, and innovation ecosystems that eliminate mutual dependence while increasing global inefficiency and development costs. Supply chain weaponization has established permanent precedent for resource control as geopolitical leverage that extends beyond current US-China tensions to affect global trade relationships. Nations with critical mineral concentrations gain disproportionate influence over countries dependent on those materials for economic competitiveness. Technological sovereignty development becomes imperative for both superpowers as economic efficiency considerations become subordinate to national security requirements. Domestic production capabilities receive massive government investment despite higher costs and reduced global competitiveness in traditional economic terms. Alliance restructuring occurs as European, Japanese, and Korean partners face impossible choices between American security partnerships and Chinese resource supplies essential for domestic industries. Traditional alliance structures strain under conflicting economic and security interests that cannot be reconciled through diplomatic negotiation. The global economy fragments into competing technological spheres with minimal interaction as mutual interdependence transforms from source of prosperity into strategic vulnerability that neither side can accept. Economic integration reverses toward autarky, despite enormous efficiency losses and reduced living standards. Military strategic planning adapts to extended economic conflict resembling Cold War dynamics, where technological competition determines geopolitical outcomes more than traditional military capabilities. Resource control becomes more strategically valuable than territorial control or naval dominance in determining long-term national power. Innovation ecosystem development accelerates in parallel tracks as both nations prioritize domestic research and development capabilities over international cooperation and knowledge sharing. Scientific advancement slows globally as collaboration decreases while duplication of effort increases development costs significantly. This analysis is for educational purposes only. It does not constitute political advice or policy recommendations. Trade war analysis involves complex geopolitical factors beyond economic calculations. All impact assessments are estimates based on available data and historical precedents.